Hello Year 9 and welcome to your lesson on the dissipation of energy. So first thing I want you to do is write down the date and the title and the LO please. You should be doing this on the 11th of January. For your starter task, I want you to watch the trailer for Chicken Run and write down some examples of the energy transfers that you see. So for example, a catapult transfers elastic potential energy into kinetic energy. So you are looking at all the transfers that you can find. There are a lot of energy transfers in this trailer. And I'll give you a hint, a lot of them involve kinetic energy and gravitational potential energy. If you are watching this video of me talking over this PowerPoint on YouTube, obviously you won't be able to click the link that I've put on the PowerPoint. But if you just type into YouTube Chicken Run trailer, it is the first video that comes up. So I want you to pause the video now, please, and go and try that starter task. I will continue in 5 seconds. Okay, so you should have seen a lot of energy transfers in that video. So the catapult I've already mentioned is elastic potential energy into kinetic energy. There's a part where a chicken flies into a fence and then bounces back off it. That is also elastic potential energy into kinetic energy. There was a part where the chickens are standing on each other's shoulders pretending to be human and they fall down. That's gravitational potential energy into kinetic energy. And then there's the machine, the pi machine, that is electrical energy into kinetic energy. Okay, and there's a lot more. Obviously I'm not going to go through all of them, but if you manage to get at least 3 energy transfers down, then well done. Right, first of all, we are going to go through the particle model. So there are 3 states of matter. That is solid, liquid, and gas. So if anyone asks you what the 3 states of matter are, all they mean is solid, liquid, and gas. And we're going to look at how the particles are arranged in the states of matter. So what you need to do is, I want you to draw what I have drawn here, please. So write solid, liquid, and gas and draw a square underneath them. And then we are going to draw the particles inside. So for a solid, they are all next to each other and they are in a fixed shape. Okay, so they are all evenly spaced in a fixed shape in a solid. Okay, so I want you to draw that and I want you to write it down. You don't need to draw as many circles as I did. Just draw a few circles. The circles represent particles. Draw them next to each other and in a repeating pattern. So they're all evenly spaced. They're all right next to each other, touching each other. And they are in a fixed shape. They can't move. Okay, next one is liquid. So these particles are still all touching each other, but they are random, okay? They are randomly spread out. Obviously, liquids aren't in a fixed shape. They can move wherever they want. So the particles aren't in like a uniform pattern. They are all over the place because they can spread out. A liquid takes the form of any container that it's in, so they need to be able to slide over each other. So I want you to write down the important information from that, please. So liquids are not in a fixed shape, but the particles are still touching each other. Okay, last one is a gas, and again, these are very random and they aren't touching each other, okay? Very random and very spread out. Now, where a lot of people go wrong is they think solids are in a fixed shape, they can't move, but they do, they vibrate, okay? So these particles, they have energy, they are vibrating. So they don't move all over the place like liquid and gas, but they still can move a slight bit. They are always vibrating. And liquids and gases can just move around wherever they want. Okay, heat can be transferred by conduction, convection, and radiation. And we are going to go through these 3 ways that heat can be transferred now. So the first one is conduction. I want you to write conduction as a subheading, please, and this only occurs in solids. Okay, so conduction occurs in solids. So what we have here is a Bunsen burner and a piece of metal. Okay, so this grey bit up here is the piece of metal. Alright, so these are representations of the particles inside. Obviously, I've drawn the circles a lot bigger than they actually would be inside the metal, but it's just so you can see it. So these are the particles inside the metal. Now, metal is solid, so therefore these particles all have a uniform pattern. They are all next to each other. As the Bunsen burner heats it up, the first particle that it touches vibrates, and this vibration, because it's touching the other particles, it passes on to the next one, and then that vibration passes on to the next one, and because they're all touching each other, as they vibrate, this vibration is passed through. These are all gaining thermal energy. Okay, so it started with this end, and as it heats up, it gets passed on. So as they vibrate, then it heats up all the way across the metal. Okay, so I want you to write that down, please. So as the metal heats up, the particles closest to the flame vibrate, and this vibration is passed on to the other particles next to it until the whole thing is warm. Right, next one, convection. So this occurs in liquids and gases. So liquids and gases, and the example I've got is in a liquid. Okay, so here we have a beaker of water and a flame heating it from underneath. As we heat up the water, the particles at the bottom that are getting hot move upwards. Okay, so they are moving upwards and they replace the particles up here. So the particles at the top get pushed down towards the heat. So all these particles at the bottom are being heated up by the flame. They move upwards when they get hotter, and that pushes the colder particles down to the bottom to get heated up. Okay, and we call this convection current. So it's constantly moving. The hot particles are going up, the cold particles are moving down, and then those ones get hot, so they move up, and then the ones at the top move down, etc. Okay, so the hot particles rise and they push the cold particles to the bottom, and this is called a convection current. Now this happens in gases too, it just so happens that I have done an example with a liquid, but it also happens in gases. So I also want you to do a subheading of convection and write down all the important information, please. And the last one is radiation. So radiation happens in a vacuum. Okay, so in space, there aren't any particles in space. It's a vacuum. Okay, so how on earth do we get energy from the sun to the earth? Because remember, the sun is where we get all of our heat energy on earth. Otherwise, it would be too cold to live on here. So in the middle, there aren't any particles, so the particles next to each other can't vibrate and pass it on because there aren't any. So what happens is we have something called infrared radiation, and that is just waves of energy. Okay, so the sun sends waves of energy that don't require any particles, and that's called infrared radiation. Okay, so radiation occurs in vacuums. I want you to write down all the important information from that slide as well, please. All right, your task. So, reduction of energy loss. I want you to draw a house and label all the ways you can think of that will help heat from being lost. Okay, so in a house, we don't want it to be cold. We want it to stay as warm as it can. I know you guys don't pay bills, but your parents do, and we want to spend less money on heating. We want to be able to keep it in and not spend as much money on heating. Okay, so an example is double glazed windows help stop heat escaping through conduction. So double glazed windows, if you just had a glass pane by itself, then that is one solid sheet and heat could easily be lost through conduction. If we have two sheets that are spaced away from each other with air in the middle, then that is stopping conduction because it's not just one sheet, it's got a bit in the middle that's not solid. Okay, so it can't just conduct all the way through, so that helps heat being lost. So I want you to write down all the examples that you can think of that will help heat from escaping from your house. Okay, and your final task. Now, this task will continue over 2 lessons, so it's this lesson and tomorrow's lesson. So today, the 11th of January, and tomorrow, the 12th of January. Attached on Show My Homework is a PowerPoint named Eco House. All instructions are included on the PowerPoint. This piece of work is to be submitted on Tuesday, the 12th of January. So if you're watching this on Monday, then it's in for tomorrow, please. The basics of what it is you've got a load of information about houses can be more eco-friendly. I want you to choose one thing, so one slide off the PowerPoint, become an expert in it, and do a poster. Use one page in your book or a double page in your book to do a poster and try and convince people why you should have whatever you've chosen in your house. Okay, so if it's double glazed windows, you need to explain all the reasons why double glazed windows will help your house become more eco-friendly, but it's all explained on the PowerPoint. Okay, I hope you have a wonderful day.